Okay, actually I started the recording. Yeah. Okay, I'm recording now. It's gonna notify all the people. Um, this is a bit of a special lecture for you watching this online, since I actually messed up the recording, meaning I didn't record yesterday's lecture at all. So today's Monday, the lecture was yesterday, and I'm re-recording it. Um, but I'm also doing it live. I don't expect anyone to show up, but yeah. So I'm gonna share my screen in Discord now, and then just start. Okay. Um, I'm feeling much more relaxed, I have to say, as opposed to yesterday. So let's start with an introduction to. Okay, so I should say this. This lecture is sort of a recap of what we've done so far in lectures 1, 2, 3, 4. Um, I have overtaken the duty to present these lectures as newest member of the C++ team on Code the Universe. And I the lectures before weren't bad, but I think they went a bit too fast, and I would have done things a bit differently. Uh, like of course everyone would do things a bit differently. So, and as I will teach the next lectures too, I'm just going to take my time with this lecture and go over the things I think you should know before we can like meaningfully do C++, because like I'm skipping around these two paragraphs here, but C++ as a language is hard. I don't want to sound like some intelligent guy. Oh yeah, I know C++. I'm so smart. I don't want to sound like I'm bitching about this. Like, oh, it's so hard. But yeah, I have my main experience is with C++, and I don't have nearly as much experience with any other language. But but to my knowledge, there isn't really another language, not even C, because C is much more basic than C++, in terms of functionality. There's no language which, in my experience or from what I know, even approaches like C++ in its complexity. There are so many things you have to think about when you're coding in C++. There are so many things which you should take note of, and and yeah. So what I meant to say by that is that people who go to learn C++ usually do it for a reason, and that reason, like, I'm telling you why I did C++, and may sound a bit childish, but I always like C++. Always when I heard about it, I had done some JavaScript, some web, some PHP before that, and some Java. Not to forget Java. And so one thing which I found like meh in Java is that you can't really interact with the system. Like of course there's a system class and stuff like that, and you can do some stuff, but like Java through its virtual machine, it's not meant to interact with the system. And always when it came to stuff like that, the thing which came up was C++. And what I had heard before I started programming C++ is that it's hard. You can do low-level stuff. You basically code right near the hardware, and yada yada yada. And that intrigued me. So That's why I did it. Reasons to use C++, of course, are speed. Like that's the main reason. Um, you know, you're not gonna go and say, "Oh, I'm gonna do 100,000 lines of code in C++." Uh, Instead of what I know, like 5,000 lines in Python. And that is in part because Python is written in C, and each import you do in Python, you should remember that each import in Python is like 10,000 lines of C++ code someone else had to do. Um, but anyways, um, yeah, this is gonna take a while. Just if you're watching this, you can just skip through the part. I'm taking nobody's time here. It's just me sitting in my room. So I have all the time in the world, and as I said, you don't have to see this lecture. Um, you should see the end if you don't know what the references are. So if you don't want to see the whole thing, just skip to the end where will talk about references. Um, but the references aren't that hard. You should be able to pick them up quite easily. Um, so C++, it's been around since the 80s. It was first developed by Bjarne Stroustrup, and it was originally called C with classes, and that that is because it originally was only C with classes, but um, of course it has evolved far beyond that. Like today, if you're doing C, like if you're doing C instead of C++, um, there'll be a reason for that. Like C is a subset of C++, and most of the time, if you're doing C instead of C++, it is because you're doing embedded and stuff like that. The runtime of C++ can be quite hard to port. You don't have a compiler. So, for example, Linux, that's the operating system I'm running right now, like Ubuntu 20. Linux kernel is entirely written in C. I don't know if any C++ in there. Maybe some parts, but like I think some parts like of the GUIs and such, of course, are written in C++, but the kernel is in C, and that is because you don't write operating systems in C++. But I'm not gonna go into that. Okay, I wasted far too much time, so let's actually get started and get through these text blocks. C++, nobody owns C++, right? So, for example, Java is owned by Oracle, which means if I want to use Java commercially, I have to go around getting licenses, I have yada yada. It's a pain, okay? And that's in part why fewer and fewer people use Java. I don't like Java that much, but I'm not saying this to bash Java. It's just that using Java as a corporation, um, when you're starting, right, you shouldn't start things in Java. Of course, there'll be stuff written in Java already, and you have to work with that. But starting new things in Java in today's age, nah, it's really not worth it. Like you could do it just as well in Python or C Sharp, and there won't be any complications. No, only that C Sharp is Windows only, but that's another story. Okay, so nobody owns C++, but it is standardized, which means there's an ISO committee. ISO is a Swiss organization, if I'm not mistaken, and they're the same people who standardize books. So at the back of each book, you'll be able to see a QR code, and that QR code has a number, and that number is prefixed with ISO dash yada yada yada. And what that means is that there's a register where you can look up every book which is registered, uh, which is registered to ISO. Oh hi, I have a viewer. Okay, I'm just gonna continue. So ISO is a standardization organization. What they do is that they have a committee which looks after the language, and every few years, since 2011, the committee releases a new standard. The standard is a PDF document, which is not public, but you can get a final draft before release, which I have here. And that is basically the same as the release, but there'll be like in here the header will be different. Here will be like final release or something. I haven't seen that document because I don't really had to use it. But this is enough to look up everything you need to look up, if you need to look it up. The thing about the standard is it's very academic and it's very complicated, and it's the last place you should look if you need an answer to a question. Here's the index. It's like 16,000 pages, 1600, excuse me, pages, and everything which is in the language is in here, and everything which isn't in here is undefined. And undefined behavior in general in C++ is really bad because there, like the name suggests, there's no definition of what should happen if you, we call it invoke undefined behavior. So classic examples are dereferencing a null pointer or dereferencing a invalid pointer and stuff like that. And like with the pointers, not most of the time, like in many cases you'll just get a seg fault, a segmentation fault, and your program will crash. That's good if that happens, because the alternative would be it'll work somehow, it'll do something, and you won't notice it. So undefined behavior is a bit strange to people coming from other languages. Because, for example, in JavaScript, everything will somehow do something. There's no such thing like if I do this expression, the value might be entirely random. But because C++ is so close to hardware, like what happens if I have a address in memory? Like I'm skipping ahead. Here we will talk about pointers in the next lecture. But if I have like a place in RAM and I access that place and I have never used the place before and there could be anything in there and the operating system might complain that I shouldn't access that and it might not. So who is to say what happens then? And who's to say if that place is valid or not? Like the program doesn't know that. Only like really nobody, how to phrase this? Nobody can say really for sure if you can access that place at one time, only if you've allocated it yourself. But yeah, I'm skipping ahead. This is all stuff we're gonna talk more about. The making of a C++ program. Now we're getting into like the basics. A C++ program is not the code itself. Like what you're running is not the text you write. What you're running is the binary translation of it. And each time you write a program, you write all the text into your .cpp and .header or .hpp.h, just header files and source files. And once you compile that, basically there's a compiler which will create a so-called object file. And that object file contains all your code and functions and stuff like that. And then after that there's the linker which will link it. It's also relatively complicated concepts to grasp. So the only thing you should know right now is there's this magic thing, the compiler. You give the compiler your source code, and the compiler gives you the binary code. And this binary code the computer can understand and the computer can run. And if you didn't make any mistakes, which the compiler didn't catch, then it will run perfectly fine and you can use it. Binary files have one disadvantage, and that is that they are platform dependent mostly. Like most of the binaries you'll compile on Windows, you can run on Windows, like even on Windows XP and stuff like that, most of the time. And same as that, most of the time when you compile a Linux binary, you'll be able to run it more or less on Linux distributions, but with Linux there's the complication that with packages and stuff like that. So yeah, but most of the time, like on Linux, software is distributed by source code more because like Linux is decentralized. There's no one Linux. There's the kernel, and the kernel itself is just like it's not even half of the stuff you use when you use Linux. But anyway, what I wanted to say is you should compile your source code for each platform you plan to support. So my viewer left, but he wrote a nice message. Okay. Yeah. Oh, the key point here is that the computer doesn't know anything about your program beforehand, or like you can think of it that it knows nothing about what you're trying to do, how you're trying to do it, but it knows it has to look for one thing, which is this function here, int main, and technically it doesn't start there. There's stuff being set up before that, but the compiler will look for int main, and if it finds int main, then after you execute your binary on your computer, all this code which is written inside the main will be executed and nothing else. From inside main you of course can instantiate classes, create threads, call other functions, yada yada, but everything starts here. If it doesn't find main, let me just do it. I'll just do int do. I can't do int init. Okay. And if I try to run this, it'll give me a linking error. Yeah, error linker command failed with execute 1. Here in function start text undefined reference to main. That is because there's a binary called the standard library, which most of the time will be either libstd.c++, libc++, or all these VC Redis stuff on Windows. And what these binaries do, they set up stuff like the stack, things like dynamic memory, so you can allocate memory later and stuff like that. And after it's done setting up these things, it'll call main, and the linker will try to link the standard library with your object file, which I've mentioned before. And if the link, and because the standard library calls, it's actually in assembly, that's the instruction call. It calls main, and this is okay in an object file, but if you try to compile it to a actually runnable binary file, or if you link that to a actually runnable file. Oh, I have another viewer. Hi. If you link the standard library to an object file and try to create an executable which doesn't have a main, the linker will try to look for it, won't find it, and will complain. So the int main function is the entry point of each program. Boy, we have a lot to go. So I'll mostly skip over this stuff here. It's pretty basic. It's just that in the language we have literals, and the best way to describe, like, it's completely obvious what literals are, but I'd say there are symbols which denote a certain type and a certain value. So, for example, 5, just like this, is a literal of value 5 and type int. A literal like this is a literal of value 1 and type double. That's because here, this point there, which means it's a rational. If I have a 2.5f, that's a float. A float can only hold, a float is only half as accurate as a double, but it's faster. Then I have like characters. This is a variable, a literal of type character, char for short, of value 65, or mostly of value 65. On most systems you'll ever encounter, it'll be 65, but you can't rely on it to work everywhere. Like if you have some, for example, if you need to write a program for your smartwatch, or like drivers for smartwatches and stuff like that, then it may be a bit fuzzy what this is. But most of the time it will be 65. I can actually demonstrate that. If I remove this and do stud just means standard, cout, and then cast a, so I'll do this. This is mentioned later in the lecture, so I'm not going to explain it exactly right now. Or maint. Sorry, here. I can remove that, and now it'll run. That's A. And A is 65. Yeah, sorry, I messed up. Capital A is 65 and lowercase a is 97 then. Yeah, and you can look it up. On most systems this will hold true. Called the ASCII table. And here you see if I look up 95 and 97, sorry, I'm a bit confused here. Then here 97 is A, and if I look up 65 here, that's capital A. So that's ASCII. Those are characters. Let's continue. Yeah, a literal. Yeah, and by the way, the string literals, we call them, which are in these parentheses. Like if I do this, hello, this isn't actually a stud string. This is not a stud string as you might expect. It is a const char pointer, which is a C-style string. And but the thing about that is I can implicitly cast, or rather I can construct a these are all like this sort of cast and construct. We'll go over them in other lectures. Cast will go over now in part. So I can construct a stud string from this. So this will run perfectly. Yeah, no errors, nothing. So that's just an interesting thing to know. Where was I? Yeah, variables. Like this is pretty basic programming stuff. Variables are just names we assign to places in memory. What I mean by that is that if I have an int I equals 5, then this I occupies a place in memory, more specifically a place on the stack, and the value in memory at that place can change, but the place itself cannot. So we can think of variables like boxes we put stuff into it, and we can just talk about the box and not the value inside it. And once we need the value, we can open the box. But there's a problem. It's not as easy as that, but basically boxes are of certain shapes, and the shape in this case means the type of the variable, and one shape cannot fit into a box for another shape. So if I do, they sort of can be converted. Casting can be think of like squishing, but for example, if I do what are primitive data types? If I do int, if I do unsigned in, I can't type. That's unsigned int equals -5. This will work, kind of, but not really, because when I print it, it'll print something like 4 billion. Yeah, 4 billion. That is because that has to do with the binary representation of this. I don't know why the compiler didn't warn me. But anyways, like there's no -5 in it because -5 can't be in an unsigned int. So yeah, but I think the meaning of a variable and what it is pretty obvious to most people who will watch this and who've come so far in these lectures. I just saw that we have another oh fuck me, I can't speak English. We have another listener in the Discord. The next thing I wanted to mention is that normally you'll see stuff like int j equals 5. The equal sign is used to initialize j, and initialize just means assign it a first value. If I wouldn't do that, j could be anything. The value of j is undefined. Sometimes it'll be 0, sometimes the compiler can put it to 0. Sometimes it can be a garbage value from RAM. The point is you can't rely on it being anything you want. So you'll, like most of the time you want to initialize integers to 0 and then like use them as counters and yada yada. But remember, before you use any variable, it has to be initialized. That it's not the case for objects which can have constructors and stuff like that, but that's more complicated. That's not something we're gonna address now. And the thing here is the equal sign is not that obvious at first. We're gonna what it does. We're gonna learn about it next lecture when we talk about classes and construction, copy construction and assignment and stuff like that. So if we have an int j, we could just as well do this and inside the square brackets put 1. And then we can do this every time we change the value of j. No, we can't do that because that actually would think it wouldn't compile. Shouldn't compile. So, what have I done wrong? Yeah, a semicolon. Oh yeah, sorry. I messed up mentally. I don't use this kind of stuff. You can't actually change the value of the variable later like this. You have to use the assignment operator, but you can initialize a value. I'm really sorry about that. Just not used to that kind of hi. I'm not used to that kind of initialization for int and stuff like that. The important thing is you can do this. You can also do this. I'll put the spaces in there, just cause. And you can also just as well do this, but you shouldn't do this because, like, for one, it's an integer. It's j is just an integer. It's not an object. So these parentheses, like, they are implying that j is some kind of object, which it isn't, because an integer is a primitive type, so a so-called primitive type. And yeah, sometimes, on some circumstances, the compiler will actually evaluate longer and more complicated expression like this as function declarations, which is really bad, and we don't want to do that, because then we don't have a variable but a function, and a function which isn't defined for one. So even if it could compile, even if it could compile a working code, the linker would complain. So anyway, that's about variables. I'm just gonna take a moment to drink. My mouth is completely dry. And drink water. It's good for you. Okay. Yeah. Where was I? Okay, arrays. We're gonna talk about arrays more next lecture, because, like, to really understand arrays, we need to know about pointers, and we should know about memory and dynamic memory and stuff like that. But for now, we can think of an array to just be a variable, which has, of course, a type. And then inside these parentheses, there has to be a constant, or a constant expression rather, which means it has either it either has to be a literal, like this, or a const expr variable, but we haven't covered that yet, and we won't for some time. Or it could be a template argument, which we won't cover in the next three. I don't know when we'll do templates, but certainly not now. So for now, we can just think of, so the important stuff you have to know, inside here, there can only be things you know at compile time. So, and the only thing you know with your current knowledge about which is compile time are literals. So for now, here we can only put literals in here. And what this does, it creates an array on the stack, most of the times on the stack. It doesn't actually have to, but all compilers which are used will. And an array is a sequence in memory which is contiguous, and it looks like this: 0, value 1, 1, value 2, 2, value 3, up to n, which is value n. And arrays are useful in that we can store multiple values in just one variable. So I can do, yeah, we can assign arrays. By the way, later in C++ in general, you'll learn that you won't use arrays that much. Basically, almost never, because we have vectors and std arrays if you really need, like, the fixed size. But anyways, these are the basics, and we should go over them. So I can assign something like this: 1, 2, 3, 4, 5. 5 only? No, only 4, because the size here is 5. Okay. If I run this, no problem. If I print the value at 0, it'll say 0. because that's the first value. Remember, always arrays are index-based. Replit, taking its fair time. Clang ++. I'm just gonna do it myself if Clang won't, Replit don't want to. Main, and oh yeah, you have to excuse my stupid mistakes. Sometimes there's just banal things like that, and /main, and we get 0. If I'll do 4, 4 is the highest. We'll get 4 because we started with 0 in the array 2. But just to show you that, just to reinforce the 0-basedness, we'll do 1, 2, 3, 4, 5. And if you run it now, yeah, again, I can't type. Most of the mistakes you'll do in programming are that you can't type, or you mistype, or misclick, or you do some other stupid mistake like that. Anyway, as you can see, the fifth value inside this array is 5, and the fifth value has index 4. Because the first value is index 0, there are a number of arguments for why that is, and I won't go over them. But basically every language follows that, except for Lua, because for some reason Lua has to be like special. I don't know. We can just do this too with an array. The values are undefined, and if you want to define a value, we can just do a 0 is 5, and we can again print a index 0, not a, r. See, I'm getting better at this. So if I run this, it'll say 5 again, and I can then assign another array literal. It's not technically an array literal, but for our purposes it is. And this time I maybe only do 3 of those. No, I won't. Yeah, I'm sorry, my basics are not that good. Yeah. Huh? An array type int is not assignable. Thought it'd be. Anyways, you don't do this anymore. Yeah, there may be something about that. Okay, so forget the last part I said. You can't do that. You can just access these values. I'm sorry about that. Also, just like the awkward things you have to face sometimes with C++. You thought you knew, but you kind of messed up. Yeah, but anyways. Let's leave the whole error things with arrays alone. One quick thing I will show you and not mention until it's needed again is Typedef. So, for example, if you're lazy like me and don't want to type out unsigned long every time you want an unsigned long, you can just do Typedef unsigned long ull, and then you can just have a ull I. Let me show you that it works. Yeah. This is one way to do it. Another way is using ull equals unsigned long. This will work perfectly too. One thing you should take away is that using statements like these are usually better, because they're easier to read if you have more complicated statements. And the second thing is it's not entirely useless, except of course if you're lazy. There's actually really useful cases where you can't do without it, and that's when you have a class and you need a member type, and the type is not constant, and stuff like that. So that is really useful. For example, if I have a, I'll just include the vector class, include vector, and then I do stud vector int value type I. This stud vector int value type, this is pretty basic. This will just be int. If I do a double, that will just be double. But there are cases in which this is really useful. For example, if you don't know this type at all, which and we will see those cases once we go into template programming and meta template programming, stuff like that. Let me just see the Discord. Someone Corno. Is there something I overlooked? Okay. Just check that it's recording. Yeah, it's been live for 40 minutes now. Good. Let's get back to it. Okay. So we've covered Typedef. Let's just go quickly about casts. The only cast you can understand right now, like with the knowledge we have, and the cast which is most useful by far, is a static cast, and this takes the form of type. I'll do it like this because we use angled brackets for templates in C++. So type name equals static cast type and then old name. And what a static cast does, it converts one type into another. So for example, if I have an int I equals static cast int, and then I'll do 1.5 in here. This is like a really basic example. I actually don't need this here because doubles can be. It will give me a warning, but it's completely legal to do. And that is because doubles can be they can be implicitly cast to ints, which means you don't have to do this static cast stuff, and it'll work. But in this case, it'll give me a warning because I could do this by accident fairly easily, and I could get some bad things out of that. So that's about what I have to say about casting for now. One thing I did want to say, which is escaping me right now. What was that in terms of casting? Let me see. Yeah. Look at the notes. Oftentimes, you'll see stuff like int I. Can change it. Int I equals int 1.5. This is easy and it's easy to understand, but it's bad for reasons. Those reasons are a bit complicated, and therefore, if you look in the lecture notes, you have a link right here which explains in this post why it's bad. Scopes and namespaces. This is fundamental. Okay, so I'm trying to someone respond to my message. Let me just drink some water and look at messages. Oh, yeah. Oh. Okay, I just took some time to drink something and engage my dear students, if I may call them that, in the Discord, which if you're watching this on YouTube, you should definitely join. We offer free lectures in programming, and right now there's a C++ course which you're watching. There's a Python course. There's a Golang course. There's a Java course, and relatively new, there's a MATLAB course too. So yeah. Anyway, continuing scopes. Okay, I've written it in here. These are, by the way, written by me. No, lecture 5 and onwards is written by me. The rest was written by Naveen, I think, or Puneet. I'm not quite sure which one of those, but anyway. Scopes. Let me use the analogy I used in here. A soldier has a scope on his gun. The soldier uses that scope to see his enemies and to aim at them, to shoot them, of course. But while he's looking through that scope, he can't see things around that enemy, and he can't see things which are coming at him and stuff like that. But the same principle of restricting what you can see is applied to scopes. Okay, and a scope is like inside the function. This is a scope. If I do this, this is a scope. If I do this, this is a scope inside. Okay, this is a scope. This is a scope inside the scope. This is another scope inside the scope. If I were to do if, this is another scope. If I do another for in here, yada yada, that's another scope. Then there's class scope and stuff like that. Basically, anytime you have these, it's a scope. Sometimes, like in functions, you can write actual code in here, like I just do std cout hello from scope 1 std endline. It will print hello from scope 1, no problem. If I do std cout hello from scope 0, get it? Then there'll be no problem with that. But there's a big but. Anything I declare, or when I'm talking variables, anything I define in here, int x equals 0, can't be seen from outside. Okay, this works. And now it says 10. Oh, yeah. We're just gonna delete this. I'll set it to 1. But if I do or try to do the same in here, it won't compile. And that is because a fundamental thing about scopes is that everything inside a scope isn't accessible from scopes above it. And anything which is in a scope above it, you can access. So int y is equals 0. Held to scope x, y. We'll do, it will print 10 now, because 1 and 0. Yeah, I have to remove this x here. Okay. Hello from scope 1, 0. And so this is one fundamental thing about scopes. You can't see everything from a parent, but if I do int j in here, I can show it to you. Like logically, same for if there weren't a scope in here, you can't see stuff which is defined later. So that still holds, but anything in here, I can see in here, and nothing in here, I can see in here. That is a thing about scopes. Let me just see if I don't want to forget something important. Yeah. Yeah, so a variable which is inside, if you're talking about a variable which is inside the current scope, it's called a local. And if not, then there isn't a name for it, basically. Most of the time, the term local refers to, I do int get 5, int I equals 4, I plus plus, return I. So I in this case is a local, and you'll hear the term local. You'll hear the term local in the context of a function like this most of the time, and when one's talking about functions and everything in function scope, so everything inside here is called a local too. So yeah, but basically anything inside the current scope is local to that scope, meaning it can't be seen outside. That is one big thing, and the another even bigger thing, which is a bit more complicated, is that, let me see, 50 minutes in, is that variables. Oh, I'm sorry about this messenger. I can't really open that right now. I might just ignore it. And another even bigger thing about scopes is that variables in scopes, once the program leaves the scope, are automatically destroyed. Let's just say if they're not destroyed, that's very bad. And what exactly happens, we'll see next lecture when we talk about classes, and specifically about destructors. And another thing I wanted to mention is namespaces. Namespaces are important. Okay, consider this example, which is very basic. Int a equals 1, b equals 2, and I make this a header, and we'll include #include library.h. And this is a library, and there's very useful stuff in that, and that's why we need it. That's why we include it. And in here, we'll do some stuff with our library. Do important stuff. And at the end, we want to display, and we'll change these, of course. At the end, we want to display the bigger of those, and there'll be some meaning to it. So, for example, the biggest possible value is, and for that we'll just define a function int may. Okay, replit is, this happens from time to time with replit. Mouth is really dry. I know that's something you need to know. Like, I have this one classmate who, like, he stands up in class and he says, "I'm going to poop," and we're all like, "Oh, okay, go do your thing." And then he comes back and he's like, and he says, "Oh, that was a nice poop," and like he's just like, he's crazy, that guy. And I'm a bit crazy too for telling you that. In a C++ course. But anyway, okay, this is taking too long. I'm just gonna refresh the page. Now it's loading. It's loading. It's downloading the file. And very good to do. So, the biggest possible value is, and for that we need a function. We'll just call it max, int max, int a, int b, and then we'll use the ternary operator. If you don't know it, I'm just gonna explain it briefly, but you should look it up. Here is an expression, and if that expression is true, this here will get executed, and if not, the second one will be executed. Meaning that if a, so this is the same, like, this is the same as if I were to say if a is greater than b, then do this, else do this. It's just a handy shorthand you can use. And so if a is greater than b, return a, and we don't need the parentheses, but I'm just gonna keep them to make it more clear. If not, then of course return b. If they're equal, it doesn't matter. So the biggest possible value is max a b. Now the tricky part is, in this library there's lots of important stuff, very important, and lots of useful stuff, very useful. I don't know why I tapped there, but anyway. And right in between that, there's this function. But let's just say this is 10,000 lines, and we don't know that. Okay. So what happens now? Well, let's just see. Error redefinition of max. Yeah. This is a basic error of this kind. This is easy to fix. This is easy to fix in this case. But for example, imagine if there were 500 functions like that, which there can be in big programs. Or even worse, imagine you made a typo in here, and you accidentally called a function from here, which does something like, if there be some stupid programmer out there which would just do I have to include something for that. Include stdio c stdio stood exit a. Okay, and it'll be just that. And if I make a typo in here, and I do just a, so you won't make this, like you won't make a mistake like this. But if it's more complicated, especially if there are templates involved, which we'll learn about later. This can happen quite easily, and our program ends at that point, which is bad. Like, I don't have to tell you that your program probably shouldn't end because you accidentally called the wrong function. Anyway, the solution to this is a namespace. Doing this will put max into its own namespace. We can, if you run this now, there's no problem, it will display 2. If it were so kind to compile, yeah. And if you want to use a library function, you'll just do lib and these two thingies, forgot the name, and it'll do the same, but we can now clearly differentiate, which leads me to the point I was trying to make. Namespaces are important. You should respect namespaces, and for that exact reason, using namespace std is bad, at least in the global scope, which means in outside a function or outside a class. And basically the rule is you shouldn't do this, and if you're advanced enough to know when you can do it, you probably don't want to do it, but if you should want to do it at that point, be free to. Anyway, so you have seen me do that, and you will see me do this. I will accept in homework and such and code examples if you prefer to using namespace std, unless no, I'll just accept it if it doesn't cause issues. But I strongly encourage you to just do this every time you want to use something from the standard library, because the cost is 5 extra characters, and it leads to clearer and better code, and it can solve a lot of bugs which don't really have to exist. This is the point about namespaces and scopes. Control structures, I don't really have to go over that. If else, you know that switch, I will do a short sub with switch. Okay. You know, if I have a lot of if-else statements, if-else, one way to just simplify that is to do a switch statement. Switch statement takes something in here, so I do int I equals 0, and I'll do I. Switch has this form, and inside the switch there are cases. As a case argument, it has to be a literal, and I don't know if it can be a const template. I think it can, but I've never seen it with that used. But the basic thing is you have these cases in here, case 2, and you have a special case called default, which doesn't have to be there, but it's handy. Okay, so case 0, case 1, case 2, and what this does is that it looks for the case at which these two values equal, and then it jumps there. So let me just show you. Std_cout, it is 0. I'm doing a mistake right here, which I'm going to explain in a few seconds. It is 2. Std_cout, it is 1. Can't count, apparently. Can't type, I can't count. There's a lot of things wrong with me. So, and the default case would be std_cout. It is I, because we haven't planned for if someone does something else. It is I, exclamation point, and n. If I do this, you probably will be surprised if you didn't know about this. It'll print everything. Everything. That is because after it jumped somewhere, it ignores these cases that are irrelevant, and it'll just execute everything which is after the point. So if I do 1, it won't print it is 0, but it will print it is 1, it is 2, and it is 1 as a number. The way to fix that is to introduce a break. And break just means jump out of the current switch. Yeah, so if I do this for every case I have, I'll do it for the default too, but it isn't required, therefore, in order for it to work. By the way, it isn't required at all. This allows us to do some handy tricks, like, for example, this doesn't make sense, but case 3, case 4, this will make it that if it's 3, 4, or 2, it'll do this, and then it'll just break. So that's one thing you could use if you wanted to. But anyway, now if I execute it, it'll just say it is 1, and it's done. One thing, if you have longer cases, what you should do is put this into another scope just to make the formatting better. And with the scopes, again, you don't have any variables here, so doesn't matter. This is basically for formatting reasons. You can just put the code into the brackets and the break outside, and it'll work. The thing to remember about switches is they are useful if you don't want to type out the if-elses. They can, under some circumstances, be faster, but in practice they won't most of the time. So people telling you, oh, should you switch whenever you can because it's faster, most of the time it isn't. And another thing to remember is always break. If I haven't said it explicitly, default will be executed if no cases have matched. So it will go through all cases, and if it hasn't found anything, default will be executed. Anyway, that's it for switches. It's gonna be a bit noisy. I'm adjusting my seat right here. Loops. I've gone over loops before. There's only one thing I want to say about loops, is that a for loop too. There are also range-based for loops, which we will go over once we have done classes and pointers, and we'll look at standard containers a bit more. And so not now. So the basic usage of for is for initial expression, a semicolon, right? Then condition and post iteration operation. Each of these can either have one expression in them, or there can be nothing in them, which sometimes is useful. There's a bit of chatting going on. Let me just answering something in chat. So, yeah, someone had a question, and I have a very loyal kernel here on our server, which is more than happy to answer questions, and I added my little stuff to that. Anyway, so this initial expression, most of the time, it will initialize some iterator or counter. So we'll just do the basic example, and I think I don't need to talk too much about what a for loop is and what it does. And should there be any questions later in the course, just feel free to ask it. There's no shame in asking questions. It takes months to years to grasp all this and to use it effectively. So we'll do 1, 2, 3, 4, 5. Then we'll do int I equals 0. That's at the beginning. That will only get executed once. I is smaller than 5. So this will run for I equals 0, for I equals 2, for I equals 3, for I equals 4. But I equals 5, I is no longer smaller than 5. And if you're working with arrays, since arrays are 0 based always in index, the basic rule is int I equals 0, I smaller than the size of the array, which is 5 in this case, I++, then I will go over each valid index in that array, which I can show you quite easily. Just see out R I and I'll print 1, 2, 3, 4, 5. Yeah. What I can do too is I'll just append an end line. I'll do a index I value, okay, like that. Print index 0 value 1. So yeah, that's the stuff about for loops. And one thing, let's just use this code we've already got to look at break. Well, just look. Okay, I was just distracted by the Discord. Sorry. Break, as said, is for break can be only inside for loops in general and switches. The break will just exit the current scope. So if I'll just do if I equals 2 break. So now we'll see that it turned 0 and 1, and then it breaked. Continue skips the rest of the loop and just goes back in here and increments I, which in our case means it'll skip over 2 and won't print it, but then just go on. So 0, 1, 3, 4. All of those are applicable in different circumstances. A return will return from a function. More on functions later. If I were to do return in here, it will basically do the same as a break. But the difference would be if I do std out end in here, and I'll just keep the break. Okay, it'll print 1 to end, and if I do return in this instance in main, of course, forgetting the basics. not really forgetting, but you know what I mean. Okay, it'll print 1, 0, 1, and then nothing. That's because at this point, return, it'll exit the whole main function. Right, another thing, the main function, this return code, 0 means you've had no problems with your program and everything ran as intended. 1 means there's been some error or a fatal mistake and you had to stop, and all other things mean awkward stuff which you can Google. So if you don't have any return statement in your main, it'll be assumed to return 0. If you return something else, it means there has been a problem. Okay, well, let's see. Functions and references. Go to, okay. So, go to is bad, except for one instance. Okay, let's say you have a for int, I'll just multidimensional arrays. I haven't mentioned those. It doesn't matter, we'll go on them next lesson. But basically, if I have an int r and do this, it means it's two-dimensional, which means that each element of r is an array itself. So I do 5 size 5, so 25 items in total. No, that's a lot of things. I don't want to type all that out. I'll just do 2, 3, and 2, which is 6. So you can declare it like this. This is the main array, and each element of it is an array itself. And not but this. Okay, so 1, 2, 3, 4. I'll just keep 1, 2, so it'll be cleaner in the examples. I'm gonna use okay. So for int I equals 0, I smaller than 3, I plus plus, smaller, lesser, classic math teacher thing. No, it's not small. If I draw it like this, it's bigger. It's lesser. You know those kinds of people. I don't. Most of the time it's a joke, but it's not funny. And I just made it, which makes me not funny. But I'm not here to be funny, but to educate you. Same as the teacher. Because I'm technically a teacher. I'm gonna just stop here. Okay. So I'll do array I, array j. This is how you access something. Then a space between that, and after the end of the second for, just a new line, and it'll print our. What have I done to upset the gods? Main 6, line 6, int array. I have forgot the last brace. Back to me not being able to type. But as you see, it works. What I'll do is I'll show you. I'll do if I is equal to 1. So on the second iteration, I'll break. What this will do, it'll skip only one iteration. It'll just keep the new line, but it won't go out. Let's just say I want to go out entirely. The easiest way to do that, and in my opinion the cleanest way, there's another I'll show you, but I won't explain it because it's too advanced, is I'll just declare this out, and then here do go to out, and this is the only the thing about this is I have to have something in here. So I think this should fix it by itself. Yeah. I'll just do a semicolon. Okay, so it goes through the first iteration, and after that, it goes out. which is nice, which is what I want to do in this case. Go to a safe in that if it jumps out of a scope, it will destroy every local and every local of the scope above it. So you can use it in this case, but if I copy this thing, this will lead to disaster, because unlike, I don't know if it even will compile, let's just see. Yeah, this won't compile, because the thing about labels, these are called labels, is they aren't position dependent. So if I just remove this, then this will work perfectly. It will be stuck in an endless loop. And that's because here go to out means go to here, which means start the loop all over again. So be careful if you use gotos to exit for loops, and you choose unique names. And a way to avoid that, which again I won't explain right now, is to use a so-called lambda. And a lambda is a function. It's basically an anonymous inline function. The way you do this is this. I have to do a reference capture. And then here, instead of go to out, you can just return. And it'll do the same thing. Yeah. But the syntax is a bit more complicated. And you have to choose if it's worth it to you. One thing you could do if, for example, you wanted to store a result, if you do so, int I equals, and then here you can return I, and after it's done, cout I, and I'll see it's 1. Oh yeah, this warning just because there's no return statement outside of this condition in here, that it may not return anything, but I know for sure in this case that it will. So it works and it prints 1. That's about it with loops. Now functions. Real quick, real dirty. You should know functions. Function works like that. You have a type, a return type, which can be void. That means it returns nothing, and you don't need a return statement. So int get 5, for example. This is a function, and in that function, somewhere I have to return a value of type int. If I'll just do this, and I'll do std. My voice is starting to hurt a bit. I have to get used to these long periods of time just talking. It's been just about 1 hour 25 since I started. Okay, so this will print 5. If I do a void, this should work, but it will do nothing. Oh no, it can't. Okay. Oh no, because it'll be a warning for sure, I think. Or will it? One thing about programming, I mean, I may look like an idiot to you if I don't know the answers to these questions. What you'll soon realize is that even like the most advanced people oftentimes don't know the most basic things. So yeah, you oftentimes have to Google. Like, there are like beginners, there are always beginners, which are like, oh, if you have to Google how to iterate over a binary tree in reverse, you're not a good programmer. That's bullshit. You're not a computer. I mean, how programming is a task. It's a difficult task, and you have your tools. You have your IDE. REPL is failing me. You have your IDE, which does autocomplete for you. You have the compiler, which actually compiles your code, like, so you don't have to write it in assembly. And you have Google and Stack Overflow and other experienced people, which can help you, because you can't be expected to know something to such extreme details as the whole C++ language and stuff like that, and making basic mistakes. Uh, if you know why, if you make a mistake and afterwards you know why you made it, and you can you can at least try to avoid it in the future, uh, that's good, and that doesn't mean you're bad. It just means you made a mistake. Certainly, this applies to most things in life as well. Okay, so if I finally try to compile this, oh, okay, then it'll be an error. But if I do just return without a value, it'll work. This function, when called, will do nothing. Yeah, so this is a function. This is like the real basic function. We'll get back to them in just a few minutes, because now it is time. I'll just inform. My mouth is always so dry. I'll just wait a few seconds if there'll be a reply in maybe in the form of a join, but it doesn't look like that. Okay, I think I'm gonna just continue at this point. Okay, so here references, I'll open this later. So, references. References are a type. You can think of them as arrays in the sense that for every type there can be a reference to that type. So, for example, if I int I equals 5, I can have an int and this at sign, which means reference in C++, if it's in a type. If it's in front of a variable and the variable already exists, then it's another thing, which we'll talk about in the next lecture. A phrase which I say so often. Doing this won't work because what a reference does, in its essence, it binds itself to the same place in memory as this I, as the variable we assign it to. So this works, and because after we have defined a reference, every time we use it, we refer to the same place in memory, and it is basically identical to I at that point. So we don't have, there's no syntactic or semantic way in which it would make sense to change a reference. If you want to have a variable reference, there are pointers, and we're gonna go over that next lecture. I feel a bit evil for saying that so often. But the thing to remember is a reference always has to be initialized when it's defined, and it refers to another variable. And now you see, if you change j, it's the same as changing I. So I'll see out I, and it'll print 1, because this is the same thing. From now on, I have declared it's the same thing, so it is. That is the law. That is the basic idea of a reference. Now, what are the actual uses of a reference? Many. I can tell you that many. We're gonna look at 2 right now, and later in the course, if it comes up again, we'll see the 2. Let me see. Recording 130. Okay. One way is to have a function which changes its input, because by default everything gets copied in C++. So if I do void set5 int I equals 5, and then in here I do int I again equals 1, set5 I, and stood cout I, and this can't be capital. It will print 1, because in this function I is a copy of the value I gave it. If you wanted to change it, we'll in fact do this. This means that the argument to that function is a reference, which in turn means this I in here points to the same place in memory as this I out here. So if I'll do this, it'll actually change the value to 5, which is what you expect if you see if you didn't know about references and types and such, and you see something like this, you would expect it to change I. I think Java works like that, or Java works like I know that Java is awkward in that respect. I think it's something like primitives get passed by value and objects by reference. Anyway, so this is one type of use case which is very common. Another type of use case is that, remember how I said in this case this is a copy of I? Well, copying is expensive. Let's just imagine, because in order to make a copy you have to create a new object, construct that new object, and if there's any data which that object holds, then copy this data. This all can be like, these are very many operations you have to do. To get around that are so-called const references, okay? And a const reference, const int j equals I. Now, I'll just show, if I try to set j to something, it won't work. Yeah. And a const reference still refers to the same place in memory as I, and it is identical to I, but you can't change it. This const means you can only do operations with it which don't change it. So, for example, j++ won't work, but j + 1 will work. Yeah, it's unused. Let me just j + 1, and right now we can think of that. We can think with primitives that's true. With objects it's more complicated. But right now we can think of const references as read-only references. So this is read only, which in turn for our function means that if we have a const int, and shouldn't do int here, I'll explain in a bit why that is, and that's a bit more advanced thing. But this const guarantees that I won't change I inside this function, and the reference also guarantees I don't have to copy. Just a thing I wanted to show you, but I forgot, is that applied like this, this operation means show me the address, and what's it bitching about again? You can assign variable I with const qualified type constant I equals 5. Oh yeah, this function, it doesn't work, yeah, because I haven't changed it. Sorry about that. Okay, so this is the address in memory of I at that point the program ran. If I'm gonna run this, and you'll see it changes, which is good. If it wouldn't change, your computer is broken, probably beyond repair. So just a heads up. But what I'll do now is that if I print the address of J, this point, it'll print exactly the same thing. That is because, as I said, it refers to the same place in memory, and as such, everything about this 2 is the same, including the address. Oh, which makes sense, of course. So, but the thing I wanted to get to is that here I have this benchmark, and this benchmark, this is a function, and what it does is it takes a string, and it goes through each character in that string, and it has a sum, and it adds the value of that character as an integer to that sum. And here I have a sum which is, and the only way these two differ is that sum copy takes a std string, which is implicitly a copy, and sum reference takes a const string reference. And as you can see right here, the reference version is 3.2 times faster. Like, that's a lot. This is unusual. That it's faster by this huge amount, but like 20 to 50% increases twice as fast is relatively common for if you micro benchmark stuff like this. And if you just need to read the characters of a string, for example, there's literally no reason to copy. In fact, there's a reason against copying, which you can see right here, is speed. Okay, so that's with the const references. But the reason you shouldn't use const references for primitives is that, okay, on 64-bit systems, this is gonna get a bit technical. A reference is basically a pointer, which is always dereferenced in practice. That's what a compiler will do. Meaning that if I have a int, like this is in order to explain this, I would need to talk about pointers. So what I'm just gonna do is I'll tell you that it's bad, and next lecture again I will explain why it's bad. Okay, let's just check the score. Something's happened. My voice is starting to scratch like really bad. And I am an hour 40 almost in. Well, if you've watched this whole lecture, I'm proud of you. Like, really, I mean that. And I'm thankful that you took the time to watch this. I know I myself wouldn't probably take just like 1 to 2 hours to watch a lecture like this. Like, I wouldn't either way, because I'm not a beginner. And there's nothing wrong with being a beginner, of course. But it's just I know this stuff. I teach it. So I wouldn't. I mean, it really means something to spend this sort of time on learning, and it means a great lot to me that you took the time and listened to me, and I don't take that for granted. And so, yeah. So next lecture. Today is the 22nd of June. Next lecture is gonna be on the 5th of July. Right, 5th of July. Thanks you all for watching, and hopefully see you on the Discord. If not, then on YouTube in 1 week. Bye.